Hello and welcome to Ocean Academe Physics 12. Rotational equilibrium. An example. A 35 kilogram girl sits 3 meters from the far end of a uniform 40 kilogram beam. If the beam is 25 meters long, what forces are exerted at each end of the beam? So as always, I want to draw what this looks like. So we have a beam, and that beam is how long? 25 meters. And there's a girl sitting right about here. And she is 35 kilograms. The beam itself is 40 kilograms. And she is sitting about 3 meters from the end. Okay, now what I'm going to do is I'm going to set up, these are my forces, A and B, going up. This is going to be my fulcrum. Now, in order to solve this, we have to look at torque. And we know that torque equals force times distance. So, first I'm going to look at force moving down, or I guess you could say clockwise. So, we've got the girl, and the girl is 35 kilograms times 9.8, that's our force, times the distance. The distance from the fulcrum would be 22 meters. And also going clockwise is the beam. And the beam was 40 kilograms times 9.8, that's the force. And the distance would be 25 divided by 2. This is going to equal what is happening counterclockwise. And counterclockwise, we're looking at force A times a distance of 0 plus force B and a distance of 25. Now, multiplying this out, we find that our force B is equal to 498 newtons. Now we need to find force A. Well, here, now, initially we looked at torque. To find force A, we look at force. So what do we have happening? Well, force, we've got going down, our force is the girl, who is 35 times 9.8, that's her force down. We're going to be adding that to the beam, which was 40 times 9.8, and that's going to be equal what's happening pushing up. And pushing up, we're going to have our force A, that's our unknown, plus our force B, which we just found was 498. Plugging in our numbers, we find that force A is equal to 237 newtons.